Okay, so we are still on the functions, and this time we are also looking at inverse of a function. We are done with domain of a function, the range of a function. This time we are going to look at inverse of a function. So when we say inverse of a function, what are we talking about? A function and its inverse. So, per the definition, we are saying that an inverse of a function is when its range or image rather maps onto its domain. Now, you know that whenever you are given a function, always the domain maps onto its codomain or range. All right, good. But the moment we say that what is its inverse, it means it becomes what the reverse. Okay, it becomes the reverse, meaning that um, the range will rather maps onto the domain. So it's like if I'm moving from A to B, then when I'm talking about it inverse, then I will move from B to A. That is what we are talking about. So let's look at these two diagrams. Now, for the first diagram, you see that we have function what f. We have this domain, which is what 2, 3, 4, and 5. Each of them mapping onto their corresponding what image or range. Have you seen that? Good. Looking at this, you see that this is the rule of the mapping. So in this case, it says that the square of the domain or the square of x, that is anytime you square an element of the domain, it gives you what its corresponding codomain. In that case, it's what range or image. So 2 squared gives us 4, 3 squared gives us 9, 4 squared gives us 16, 5 squared gives us what 25. So that is what um the rule, and this is what the function itself. This is what the function itself. So if we say find its inverse, what does this inverse mean? Now let's look at the second one. So you realize that this time all the values you saw here as the codomain or the range or the image, this time they start first. Okay, and those that began rather what ending last. So it means that we have done what a reverse. So we moved or we mapped the domain onto its range, but this time we are mapping the range onto their domain, and that gives you what this it's what inverse. So that is what we are talking about, what the inverse. So the reciprocal, okay, the reciprocal or the reverse of that of the rule also gives what the square root. So it means that in the function the rule was given as what the square, okay, but when you take it reverse it becomes what square root. That is what we are talking about. So we are saying the reverse of a function f gives its inverse, denoted by f superscript what -1, and that is what the f inverse, that is the inverse what symbol or the inverse notation. All right, good. Now one thing you should take note is that for a function to have its inverse, then we are saying that that function must be what bijective. Okay, so we are saying that an inverse function, okay, an inverse must be what must be bijective. Yes, so for a function to have its inverse, then it means that that inverse of the function should be what? Bijective. And when we say bijective, what do we mean by that? When we say a function is bijective, then that means that that function should be both what? Injective and surjective. Injective and surjective. In a previous video, I made mention of injective, 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 and what? Surjective. Injective and surjective, these two words. Okay, when we say injective, what does it mean? We have already said that injective, we are talking about when the function is what? One to one. When a function is one to one, when we have each element in the domain, okay, each element in the domain corresponds to only one element in the codomain, then we say that function is what? Injective or one to one. But when we say surjective, surjective, it means that when you realize that the range of the codomain or the range of the function is equal to the codomain or is the entire what? Codomain. In other words, we can also say the surjective is also called what? Onto functions. When we were dealing with types of functions, we made mention of onto functions. So this one we are saying that it is what? The same as one to one function, and this one also the same as what? Onto function. So onto function we mean when the range is the entire codomain or the range is equal to the codomain. Yes, so before a function can have what? Inverse, or an inverse of a function must satisfy these two. It must be what? Bijective. In that case, if it is bijective, it means that that function must be what? Injective. At the same time, it must be what? Surjective. All right. Other than that, then we can't have the inverse of a function. So why are we saying that? So looking at these two examples here, we can say that is what? These two example, or this example you see here, is what? It is bijective. That is, it is injective, which is one to one. You realize that one to one, every element maps onto only one. Every element maps onto only one. So once it is one to one, then it is what? Injective. And let's check whether it is also surjective. So when we say surjective, it means that when you realize that all the range is the entire codomain, or is equal to the codomain. So looking at here, you realize that each of the element in the codomain corresponds to each element, or it corresponds to what? Element in the domain. That makes it what? Surjective. It means that all these are the range. At the same time, all these are also the codomain, meaning that they are the same. And if they are the same, then we can say that this function here is what? Bijective. Okay, so it is both injective at the same time or surjective. That is, it is both one to one at the same time what? Onto function. Once you realize that that function is like that, then we can have its inverse. Okay, if the function, if you realize that the function is many to one, it is many to one, then finding its inverse becomes very difficult. That's why we are saying that the function must be what? Bijective. Okay, so that is how we can find the, or that is how we can say, or that is what we can say about inverse of a function. So when you are given a function, so if I give you f at x to find its function, then its function is denoted by what? F superscript -1. You can write this, or you can bring the x here. If it is j at x, then its inverse is given as what? This. Okay, h at x also gives me h like this. There are times that we may even ignore the xx here. It makes the same thing. All right. So that is about what inverse of a function. That is the reverse of the function. Now, in our next video, we are going to look at how to determine the inverse, or how to find the inverse of a function. All right. So we shall end here and continue in our next video. So I will want each and everyone to stay calm and watch out for the next video. All right. So see you there. Bye bye.